Now we're diving into chapter 6, two sections, 6.1 and 6.2. They basically involve area with curves. Okay. So if you recall with integrals, we're finding the area underneath the curve. But in chapter 6, we're dealing with multiple curves, or the area between different curves, or rotating them around the x-axis or the y-axis. But in this specific section, we're going to talk about the area between two curves. And what do we mean by that? Well, let's say we have, conceptually, we have, here's just a random graph, and we have a couple different little curves right here. Like I'll call this graph f of x right here, this top one. And then I'll just have a little other, random curve doing something like this right here. And I'll just call this g of x. Now, what would happen here if we wanted to find the area, and I'll call this, this marker's dead. We have these 2 points, A and B right here. And we wanted to find the area between these two curves. Well, remember, if we were to find just the integral from A to B of f of x, that would be giving us all this stuff down to the x-axis. Or if we were to find the area of g of x, the green curve from A to B, that would give us the area of basically from the top of this green line down towards the x-axis. But what about if we wanted this stuff in between, right? Like that would be the area between the two curves. How will we do that right there? Well, if you found the area of the f of x, right, and you subtracted that from the area of the green of x, what would be left over? The purple stuff, right? Or the area between the two curves. Now, how will we go there and compare that? Well, the area, I'll just call A, from A to B in this case, would be the f of x minus g of x dx. Or another way of looking at it is this right here. I'm going to say from A to B still, and I'll put y t minus y b d of x. Now, what does this mean right here? The y b minus y t minus y b d of x. Well, y means our equations in terms of the y, okay? And it means top minus bottom. So you have your top equation minus your bottom equation. And this is important because sometimes you can have the right equation minus the left equation. So what denotes, do I do right equation minus left equation, or top equation minus bottom equation? Well, if it's with respect to x, okay, like in this case right here, this is with respect to x, y, because this is f of x and this is g of x right here. That's what we mean by y equals in this instance, okay? So this again really important is with WRT with respect to x. And we will do in a few minutes, or after a couple of problems, we'll do it with respect to the other variable, or with respect to y. Again, how do you know the difference between that right there? Well, normally, if you have your equations in terms of y equals x to some power, that denotes right there you're doing it with respect to x, okay? But if your equations have like y squareds or y cubes or y to any other power higher than 1, then you're going to be doing it in the reverse direction, or you're going to be doing it with respect to y instead. When I say this phrase with respect to x, it means that all stuff inside your integral have to be just variables only. Also, this is dx right here. Okay, so let's check this out. Let's do a few of these with respect to x. Now, normally these are going to be very specific, okay? They're going to say, oh, in the area between two curves, or find the area of the region bounded by a couple of equations. Bounded by, and let's just say y equals x and y equals x plus x squared plus 4, and bounded by or bounded on the sides by x equals 0 and x equals 3. So whenever you're doing these problems, it definitely helps out to draw a sketch of these curves, and then you can shade in, what they're asking you to look for. So if we drew a rough sketch of y equals x and y equals x squared plus 4, what is that? Well, y equals x is just a nice old, diagonal line that runs through the origin, right? That's y equals x. And y equals x squared plus 4 is a parabola, right? And it's just basically a parabola that's been shifted up 4 units. So it's doing something like this right here. What is this? They told us, oh, they want us to find the area between the curve between x equals 0 and x equals 3. So pretty much here's 0 and here's 3, right? So they pretty much wanted this stuff right here. That's what they're looking for, this blue right here. Now, will they always give you these sides right here, like bounded on the sides like this? No, sometimes they won't. And that's what we're going to be doing right after this problem right here. If they give you the sides like this, the problem is very easy, because that's normally the hardest thing to find out is your limits of integration. Like, where are you integrating from what to what? Now, with this one, we know we're doing it with respect to x. Why? Because telling us, oh, x equals something, x equals something. And also, we don't have any crazy powers of y. You don't have like y squared equals x squared plus something like that, okay? So, since we're doing this with respect to x, let's see. Here we go. Back. Since we're doing this with respect to x, right? When you're finding the area between two curves with respect to x, it is always the upper curve minus the bottom curve. Okay? We know we're integrating from 0 to 3. All right? Now we just figure out what's the upper curve, what's the bottom curve. Well, the upper curve is obviously the one that's higher up the x-axis, right? So this one, it's your parabola. It's x squared plus 4. And then minus the bottom curve. Well, the bottom curve is y equals x. And it is important to keep all these in parentheses, because sometimes your second function, or you're subtracting, is going to have more than one term. And if you have more than one term, then you need to go out there and remind yourself, oh yeah, you're going to have to distribute that negative sign, into that whole thing. Of course, we're integrating with respect to x, correct? Dx right here. Remember, if it's dx, everything has to be in terms of x all the time. So now that we can go out there and write this problem. So, drop the parentheses, right? We just need to apply the negative right here. It's still the integral from 0 to 3 of x squared plus 4 minus x dx. And now we can just basically take the antiderivative of all this stuff, right? There's no u substitution that's involved right here. These are just very straightforward terms. This is 1/3 x cubed. And then I'm going to integrate this x because I'm going to put it in descending order, right? This is like x squared minus x plus 4x right here. So then minus x, the antiderivative of that is minus 1/2 x squared, and then plus 4x. And then this is evaluated 3 to 0, right? Then pretty straightforward. Just go ahead and take your time. Arithmetic, remember, it's the upper limit minus the bottom limit. So remember, we're plugging 3 in to all these x's for the limit, and then we're subtracting the entire bottom limit. So this is 1/3 times 0 cubed minus 1/2 times 0 squared plus 4 times 0. But what nice is, since these are all zeros, right? All this is going to cancel out to a fat 0, so that's nice. So really, we just need to figure out what is all this stuff. And remember, if you want, you can use a calculator. Right? Well, we know that this is 3 cubed is 27 times 3 is 9. So we get 9 minus 9 halves plus 12. Get that right there. All right, so let's see what we get. Crank this all out and LCD and all that, get 33 halves, like that. That is your area in this instance right here. Again, it's just the upper curve minus the lower curve whenever you're confused right here, and it helps draw a rough sketch. You can see which one goes first, because if you put x first minus the x squared plus, you're going to get a completely different answer or the incorrect answer. So when you're doing it with respect to x, it's always the upper curve minus the bottom curve. And as I mentioned before, sometimes they'll give you limits. If they give you the limits, then again, that's the hardest, is trying to figure this out right here. Sometimes, many times, I won't specify that. Okay. Like, let's check out problem like this. Find the area of the region bounded by y x squared and y equals x plus 6, for example. Now, in this instance, they did between x equals, 10 and whatever, 16. They just said find the region bounded by these two curves. So this is another reason why it's important to draw out a rough sketch, because in particular cases, when they don't give you limits to integrate from, you figure out, okay, what are they talking about? Bounded by these two curves, what does that mean? What y equals x squared look like? That's just a generic parabola that runs through the origin, right? That's x squared. And then plus 6 is a straight line, but it's not going to run through the origin. It's just shifted up 6, right? So put this is 6. So it does something like this right here. So what are they looking for? They want this stuff. Okay, that's what they're looking for. The area of the purple stuff. Well, we need our limits of integration. If they don't the limits of integration, what you need to figure out is where are the lines intersecting. So lines, how are we going to figure that? Well, the lines intersect when we put them equal to each other. So when squared equals x plus 6. Now, how did I get that from these two right here? I substituted, right? You know, it doesn't matter which substitute into is equal to x squared in this case. What if I plug in x squared plus y? What do you get? You x squared equals x plus 6. Or you could do it the reverse way. You could say, hey, wait a minute. Could I take this equation and plug it into y? Absolutely, right? Because again, y for this one says it's equal to x plus 6. What if I take all this x plus 6, and I jam it into this y? You get x plus 6 equals x. It's the same, right? So it doesn't matter substitute this equation into this or vice versa. You're still going to wind up with the same kind of equation. So how do we figure this out? How do we figure out what x is right here? Well, you're going to have to set it to 0, right? Anytime you have a variable ratio higher than 1, solving for that specific variable, you need to set it to 0. So this is basically x squared minus x minus 6 equals 0, right? Because I'm just moving the x and the 6 other side. And if we're going to do factor, oh, so we solve these, x equals 3 and x equals negative 2. So basically, that's these points right here. This is negative 2x. This is positive 3 for the other x. That's where they're intersecting at. That's what we need, right? Because with this problem, we will be integrating with respect to x. Why? Because we don't have like y squared or anything like that, or y cubed or the fourths or some power other than. So now let's figure out our integral. What would our integral look like in this case? Well, we know we're going from negative 2 to 3, and it's the upper curve minus the bottom curve. What is the upper curve instance right here? It's the one that's bounded, the higher curve that's bounded when of with respect to the shaded region that you're trying to find. So you're not going to say, oh, it's the x squared. That's the higher curve. No, we're only looking at this component, right? This is looking for this. That's all that we're trying to, this purple stuff right here. So the upper curve instance is the x squared or the x plus 6. Well, it's a straight line, right? It's the x plus 6. That's the upper curve right here. So it's x plus 6 minus the bottom curve. Well, the bottom curve, or the bowl in this case, is the parabola. All right. See, upper curve minus lower curve. Go out there and work it out. So I'm just going to, again, drop the parentheses. So there's nothing to read except that negative sign. That's negative x squared right there. This is just x plus 6 minus x squared, right? Dx here. But I'm going to, in descending order, highest power first. So this is negative x squared plus x plus 6, and then dx, like that. And then we're going to take the antiderivative. And again, we don't have any kind of u substitute right here. This is negative 1/3 x cubed plus 1/2 x squared plus 6x. And you're going to evaluate it from 3 to negative 2. This one, be very careful, right? The signs. negative 1/3, and then we're gonna have 3 cubed plus 1/2, 3 squared plus 6 times 3 minus the entire bottom limit. Unfortunately, this is not a zero term. So this is negative 1/3, and then you're gonna have negative 2 cubed plus 1/2, and then negative 2 squared plus 6 times negative. Now, when you crank all this out in your calculator, taking your time and everything, watch the signs, right? Remember, work all this stuff out first, then apply that negative right there. But work it all out, you should come up with 125/6. So no decimals, okay? You want them as fractions, right? Unless the computer or whatever asks you decimals, but most of the time they're gonna want you to leave it in fraction. Okay. So again, the trick to is drawing out the curves, because there's two mistakes that people make a lot with these. The biggest one is the limits. If they don't the limits, you need to find the limits. How do you find limits? You need to set the equations equal to each other and solve for x in instance, right? Y for not for y, because we were integrating with respect to x. Why are we integrating with respect to x? It's because we didn't have y squared equals blah blah blah, or y equals blah blah blah. That's the first mistake, the limits of integration. The second mistake is that people get the order in how they set curves. Remember, with respect to x, it's the upper curve minus the lower curve. You have to get that order correct. So those are the two mistakes: it's limits and the order in which they write out their two equations. But again, as far as how each equation comes first, draw the sketch, right? Draw a rough sketch. That will tell you what's the top and what's the bottom. Like, what if we try, say, for example, let's look at this one, y equals x plus 2, and y equals 4 minus squared. Let's look at these two equations now. Notice no limits were given. So that tells you, oh, we have to look for where do they intersect. But let's go out there, draw, and let's draw a rough sketch. X plus 2 is just a nice straight line again. That's just shifted 2 units. Remember, when I'm saying it's like shifts up, down, left, right, flips, or whatever, those are transformations, right? So if you need to go and look, like if you're asking how you know that this thing went up too, it's just shifting. There's vertical shifts, there's horizontal shifts, and there's reflections, right? Reflections about the x, y axis. Those are transformations. If you need to go back and look at rules, that was from your Math 130 course. You can go to Google and type in transformations of, and they'll give you all the rules and little practice problems. So that's x plus 2. 4 minus x squared. What's happening right here? You have a vertical shift of up, and that negative in front of the x squared makes it reflect upside down. It opens downward. So that's this thing right here. This is 4 minus x squared, and this is x plus 2. So now, what do they want in this? They want this. That's what they're looking for right there. So I'm going to get rid of this extra stuff. Just to kind of minimum what we're looking at, just really this we want, right? We want this little area right here. Now, we need to figure out where do you intersect, right? Like, what is this point? And what is this point right here, right? What's the x value? What are these two values right here? How are we going to do that? Well, we have to find where they intersect. So they intersect well, when we set them equal to each other, when x2 equals 4 minus x squared. And again, it doesn't matter if I plug this one into this one or this one into this one, you same thing. Where are we plugging it in? Y is equal to x plus 2. Remember, we could be taking this and into this y, right? Because the relationship for this equation says y is equal to x plus 2. Or I could take the opposite. I could take this, right? Because this relationship says, oh, y is equal to 4 minus squared. So I could take this and plug it into this y. If I did, I still get the same equation, right? These are flipped sides. It's still the same thing, though. So now, how do we solve this? Well, again, because of an x squared, some x, the power 1, we're going to have to zero factor it, right? Now, we always want the dominant term to be positive, meaning the one with the power. This x squared is the dominant term, but it's negative. We want it to be positive. So what I'm going to do, bring it to the other side. We want that to be positive. We want the dominant term positive because it just makes it easier when we're factoring it when it's a positive term. So yeah, we're going to add the x squared to both sides. Also, let's move that 4 over as well, and I'm going to subtract 4 from both sides. In doing so, what do we ultimately have? We have x squared, this x staying plus x, and we have 2 minus 4, which is 2, and all is equal to 0. And then factor this right here. This is x plus 2 times x minus 1 equals 0. So we can see, oh, they're going to intersect that x equals -2, right? Where am I getting that? Because we still have x plus 2 and x minus 1 equals 0. If we set these both to 0 and solve for x, we get x equals -2, x equals 1. So that's what these values are right here, -2 and 1 in this instance. So now we can set up our interval. We'll say A, the area, is equal to -2 to 1. And now since we're doing it with respect to x, it's the upper minus the lower curve. What's the upper curve in this instance? Is it the straight line? The parabola that we were looking at? It's the parabola. It's the 4 minus x squared because that's the high one in this instance. So we're going to have 4 minus x squared minus variant straight x plus 2. You need to put that whole thing inside of in the parentheses, right? Because that's going to signal us, oh yeah, we need to subtract this entire equation. So we're going to distribute that entire negative sign into both terms. In the other two terms, we only had one term. So if you forgot the parentheses, you still get it right because negative is only being applied to one term. But right here, you need to make sure, oh yeah, I need to apply this negative to both terms. So let's just write that out. So 4 minus x squared minus x minus 2 dx. I'm going to put it in descending order. This is x squared minus x plus 2, because minus 2, right, is positive 2 dx. Please don't forget that is the top equation minus the entire bottom equation. Use the parentheses to remind yourself, oh yeah, I need to distribute the negative to these terms right here. Because if you do this, which is a mistake that a lot of people do, then they only say, oh, negative, and they keep this as positive 2. No, that 2 also change signs because of the negative, right? Sure, you subtract the entire quantity. So now that we have this, we can take the antiderivative. This is negative 1/3 x cubed minus 1/2 squared plus 2x. You're evaluating it from 1 to -2. So watch the signs again, right? Also, we don't have a 0 that we're plugging in one of these limits. It's the upper limit minus the entire bottom limit. Watch the signs, minus open parentheses. You're going to have negative 1/3 times a -2 cubed minus 1/2 -2 squared plus 2 times -2. What's the sign specifically right here? This first chunk is a positive, right? Because negative raised to an odd power, negative times another negative is a positive right here. Make sure y'all, again, work these out. You remember your calculator, it has that ABC button, right? That the fractions right there. Like if you need to say, you work this out, this will be positive 8/3. If you had to type that in, it'd be 8 ABC3. And then you add it to this one right? This is 2 squared. -2 squared is 4 times the -1 is a -2. So you would say 8 ABC3 and then -2. And this becomes -4, like that, right? That's how you would type it, that entire bottom limit right there. And it gives you this fraction right here, -3 1/3. You need to convert that right into an improper fraction. That would be -10/3. But notice that minus sign outside, right? Where's that from? That's this one right here. Then you do the same thing for the top. This is what? This is 1 cubed is 1 times a -1/3. That's a -1/3. And then this is a half, minus 1/2, plus 2, minus a 10/3. When you work all this out, again, you would use ABC button. ABC button's right here, correct? C button right here. That's it. Put it all in. If two, when you put in negative numbers in your calculator, you cannot use the minus button. Look, there's a difference. This negative sign, minus negative. You see the difference between a negative and a minus? If you're -1/3, you'd have to put negative down here, 1 ABC3. And then for the half, well, that is a minus sign. You'd use the minus sign, 1 ABC half, then plus 2 and plus ABC 3 plus y, because you have negative, which is the positive. And let's see what comes out right here. So, and 1/2. But we don't want mixed numbers, right? We didn't convert that right there. Well, could just remember from, back when we learned initial fractions to convert from mixed to improper. What you do, you say whole number is denominator plus numerator. 4 times 2 is 8 plus 1 is 9, and the denominator stays the same. What you can do is, if you get a number on here, you can go and press whatever answer that is a mixed number, press second and press the ABC button. And it's going to do that. It's going to convert to 9/2. So what did I do again? Let's get a mixed number, okay? Like, let's say you have 7 AB 3/8, something like that, right? That's what happens. You computed something. I'm making this up, okay? If you want to convert that to an improper fraction on your calculator, just second ABC button. Notice, look at that notation. What does that say? It says, oh, ABC converted to D over C. It's just converting from mixed number to improper fraction and hit enter. And you get 59/8. But again, the way to do that without a calculator is, again, it's whole number times denominator plus numerator. 4 times 2 8 plus 1 9. But don't forget your denominator. So there's your final answer right there. 9/2. All right, so that's how you do, or you find the area between two curves when you're integrating with respect to x. What about if we integrate with respect to y? Like, what if we integrate between two curves? Finding the area between b/t between two curves, integrating WRT with respect to y. Does that work in this case? Well, we're still subtracting two curves, but now I have this XR minus XL and then DI. So slightly different notation, right? If you notice right here, this is DY right here. And our X's instead of Y's. Our first one with respect to X, we had YT minus YB, Y the top equation minus Y the bottom equation. Now with R is right. The rightmost equation minus leftmost equation. Actually, what does that mean right there? Well, say we have a curve or a couple little curves. Like if you had something like this, for example, just making this up right here. Let's say we had two curves right here, okay? And we're rating with respect to y. So when we rightmost equation minus leftmost, well, first of all, we're for this. So if we rightmost minus leftmost, so this is your, this would be your XR right here, straight line right here. That would be your XR, because that's the equation furthest to the right. That's the one bounding to the right. Don't say, oh, well, this arrow right here is shooting more on the right. So no, it's because this thing here, according to this shaded region that we wanted, what's the right piece? Is the bowl, the sideways bowl, or the straight diagonal line? Straight diagonal line. And then what's your leftmost equation? Well, in this case, be the bowl, right? It's this right here. That's what we mean by rightmost minus leftmost, like that. And really important too, with this x minus xl, what does that mean? It means that equations in this case they must be in terms of y. What does that mean? It basically means to have x equals blah blah, like that. So remember when we were integrating with respect to x with the equations, remember all the equations were in terms of y, right? Like y equals, and it was all just x stuff inside the integral. And this is the reverse. You have a bunch of y stuff in here. That's how that works out like that. And how do we know? Oh, we're going to integrate with respect to y? Well, there's two ways. One is the problem will just tell you, like, in directions, it's going to say do it with respect to y. Okay. Or the other way is they won't say jack squat, but the way the equations are arranged, that's how you'll. As I've mentioned before, the biggest indicator power of the y. Okay. So if we look at this example, like y squared equals x and y equals x minus 2, we want to find the area of this region right here. So this tells us big indicator, oh, we're going to be doing it with respect to y. It's because we have a y squared, okay? And again, it doesn't have to be a y squared. If it was y to the 10th, any other power of y to the first equation, or even that you should integrate with respect to y. So first, let's draw a picture, right? So we can see, oh, to kind of an idea of what exactly we are looking for. So y equals x minus 2. Sometimes you'll get combinations of stuff, right? Like this one's pretty straight. This is just a straight line that's been shifted down to. It's like a dash. It's gone down to like this. So we have this. This is y equals x minus 2. This y squared equals x. How do you draw that out, right? Like, because we've never, for some weird reason, we've never really looked at y squared stuff ever. It's just the first time we've all seen it is in Calc 1. It was even the first I saw that. But how do we go out there and grab y squared stuff? Well, what you can do is let this and solve y, right? How do we solve this for y? Let's take the square root of both sides. This is going to help us give a good picture. To do that, I'd have to take the root of both sides. If I take the root of both sides right here, y equals plus minus the square root of x. So y squared x and y equals plus or minus root x, those are the same equations, but we know what this looks like, right? Like, what the square root of x look like? That's this, right? What's the negative square root of x look like? It's the same thing, but if you take a negative and you throw it on the x like that, what are you doing? That's a transformation. A negative out front flips it over the axis, so it does this right here. So this is negative root x, and this is positive root x right here. Again, that's a trick that you use when you need a graph like y squared equation, just for y, and you're always going to have a plus or minus version of something out like that. Now we can see, oh, look at the area that we're trying to find. Is right here. We're looking for that. But we're doing this with respect to y, correct? About that. So because we're doing with respect to y, we need something, right? We need our limits. Our limits get, well, we still sit here and set them equal to each other, but remember, this is in terms of integrating with respect to x. We're not going to have how we did before when we had a bunch of x components equal to each other. We're going to have, like in x equations, we had like x equals blah, blah, blah. We're going to have a bunch of y stuff or y equations equal to each other. So your limits, are they going to intersect? And y equals x and y equals x is 2 are equal to each other. I'm running space. So I'm going to do that, right? So our equations must be in terms of y. How we do that right there? Well, look, basically we need to isolate x in both of these cases. Okay, isolate x. This one's already isolated. We know we have x equals y squared. That's done right there. How do we isolate x right here? Well, if we have y equals x minus 2, then what is x equal in this case? X equals y plus 2. So that's our second equation right here. So where we from here, we're going to set these equal to each other, but with respect to x. So now I have y squared equals y plus 2. So you see the difference when you are integrating with respect to x. What did our intersection stuff look like? We had all x equations, correct? Everything was x equals x squared equals yada yada yada, like that, all x stuff. You're integrating with respect to y, the reverse. All your equations need to be in terms of y time. So some of them you might have to rearrange, like right here. I had to rearrange because again, I had to get it said it was x equals something. This one already said x equals something or x to the first. We always had to get that x first, x to the first, like that. So when you're in with respect to y, you need to figure out your intercept. It's got to be all y like that. Again, yeah, maybe some of them will require some manipulation. How do you know if an equation will require manipulation? It's because x is not by itself. You have x the first by itself, then you're right. That one's already done. If not, then we got to move some stuff around. So let's take this and solve y. That's going to give us our numbers, right? That will intersect with respect to y. So because we have a y square, we need to set this to 0. We need to keep this term positive. So this is because again, it's the down term. So we're going to move this to the other side. This becomes y squared minus y minus 2 equals 0. We factor it in. So we get y equals 2 and y equals -1. So let's go back to the graph, right? Again, we're just talking about this is the only stuff that we need right here. Now, when they give us y equals 2 and y equals -1, those aren't the x values. Remember, with the other problems, I was going along the x-axis saying, oh, we're going from here to here or something like that. But this is with respect to y this time. So this is, they intersect at y equals -1 and y equals +2. So reverse, correct? Remember the x ones, you're going from left to right to figure out where they intersect. With the y, it's up and down, like that. Now, we have our limits. So -1 to 2. But now, not the upper curve minus the bottom curve. When you are integrating with respect to y, it's the rightmost curve minus the leftmost curve. So what's the rightmost curve right here? Remember what's the rightmost curve according to this shaded purple region right here? The right, it's this diagonal line. What is that case right here? Is a diagonal line the y squared or this one right here? It's this. It's this. But very important though, you're not gonna put x minus 2 right here. No, it's got to be in terms of y. So what is that in this case? It's this. It's y plus 2 right here. So you're gonna have y plus 2 important. Why? It's got to be in terms of y this time. When you're integrating with respect to x, everything was x stuff. But because we're integrating with respect to y, it's got to be y stuff. So we have to use our manipulated equation that we got right here when we were trying to figure out the intersection. And it's minus the leftmost equation. What's your leftmost equation in this case? The y squared. And then it's dy. So that's another mistake that people make, because with the integrating with respect to y is it's the rightmost equation minus leftmost. Really important. You got to use correct rightmost equation. What I mean by that is you can't say, oh, x minus 2, use that down here. It is that x minus 2 is rightmost equation, but it's got to be in terms of x. When I say terms of x, I mean x to the first equals blah, blah, blah. Or if I say in terms of y, it means y to the first equals blah, blah, like that. That's what we mean by in terms of a variable. We need to solve a specific variable. Very important. You have, for some of these, you are going to have to manipulate them. Now that we have this, we can go there and begin to derive. But before we do that, though, I'm just going to drop parentheses and put it in descending order. This is negative squared. That's the dominant term, so that comes first. And then plus y plus 2. And then we have dy. So now let's go there and take the antiderivative. So I know we've only been doing dx's the whole time, but it's still the same concept. It doesn't matter if it's dy, d, d whatever. It's still the same rules. So the antiderivative of a negative y squared with respect to y is still, it's just negative 1/3 y cubed, right? It still follows the same rule. If this was negative x squared dx, what's the antiderivative of negative x squared? It's negative 1/3 x cubed. Same concept. Antiderivative of y with respect to y is a half y squared, right? It's still the power rule for antiderivatives. And then the antiderivative of 2 with respect to y is just 2y. And then you evaluate from 2 to negative 1. So you can just watch the signs, right? So we have the upper limit. Minus the bottom limit. So minus the entire quantity, right? Negative 1/3, negative 1 cubed plus 1/2 times negative 1 squared plus 2 times negative 1. So carefully simplify all that stuff. And if you get it right, you should come up with, you are going to come up with 9/2. So I know in the last problem, we also came up with 9/2. It's just a coincidence. Okay. Just a coincidence, right? So the biggest thing is when you're doing it with respect to y, if we're integrating with respect to your equations, all have, remember when we set it up, your equations had to be in terms of y. You had to have x equals for every single equation, and some you may have to rearrange, right? All right, so let's try another one. Like say we have y equals minus 1 and y squared equals 2x plus 6. So again, with this one, integrate with respect to y, but the y squared, okay? Biggest indicator right there. They didn't give us the boundaries. They didn't say between y equals 0 and y equals 5 or whatever. So we're gonna have to figure out, where do they intersect? Well, where can we see that? Well, let's go out there and draw a rough sketch, right? Let's do that. X minus 1, that is just, a diagonal line, right? That's just down one. Now, how are we going to graph y squared equals 2x plus 6? Remember, we can sit there and isolate x, right? Isolate y by taking the square root of both sides. If I do that, I get y equals plus minus the square root of 2x plus 6. What is this right here? This is just a radical that's been shifted 3 units to the left. How do I know it's been shifted 3 units to the left? It's because if I take the inside and I set it to 0, right? Like if I say, 2x plus 6 equals 0, you get x equals -3. So starting at -3, that's where it's basically shooting off from. So it does this, the positive version of it, and then the negative version is it just flipping over the x-axis. So again, this is positive square root of 2x plus 6, and this is the negative version down here. So what are they looking for? They want this, the green stuff right here. So we know what the rightmost curve is, right? If again, you can ignore all other extra stuff. If we just look at this, the green stuff, what's the rightmost curve? It's the diagonal line, correct? And then we know that the leftmost curve is the purple, or it's this y squared 2x plus 6. But let's figure out where they intersect, right? Where do these things intersect at? How are we going to figure out where they intersect? How are we going to do right there? Since we're doing this with respect to y, we need to have x equals blah, 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 right? X equals for both of them. We need to sit here and we need to isolate these both for x. So isolate both equations for x. Well, this one is just, if we were to do that, is x equals y plus 1, right? Got, that's done right there. And then right here, what can we do? How do we isolate that right there? So how do we this and solve for x? Well, gotta do things right. You subtract the 6, right? So we have y squared minus 6 equals 2x, and then divide by 2. You get, I'm gonna put it up here. We have x equals plus 1. And then we also have right here x equals, and this is y squared minus 6 over 2. So again, why are we doing this? Again, we're integrating with respect to y. We need to figure out these inter with respect to y. So I have to have set my two equations equal to each other, right? So to do that, I have to isolate x. I have to have x to the first equals blah, 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 both of these instances. Now we're going to set these equal to each other. Solve for y. So kind of crazy little equation, right? But it's not too difficult. If fractions are to get and you equation, how do you get denominators? You multiply everything by the LCD, which in this case is 2. So we multiply left and right side by 2. These two go. We have 2y plus 2 equals just y squared minus 6. Okay? So now we need to solve this for y. We're going to have the y factor because you have a y to a power 1. We'll keep the dominant term positive. So we're going to move stuff from left side to the right side. So I'll subtract the 2y, 2 from both sides. So what does that leave with? We have y squared equals this negative 2y. There's nothing to combine it to. Do not go to 2y minus 6 because I just wrote one under the other. You can't like terms. So this just you drop it. Wait a minute. It's still y squared minus 2y, but this is 6 minus 6 2, negative 6 minus 2 is negative 8. All that's equal to 0. So now we can factor this into y plus 4 times y plus 2 equals 0. So y equals 4 and y equals negative 2. So again, what does that represent here? That's representing this. This is y equals negative 2. And this is the y value four. So what is our integral going to look like? We have a equals, so from negative 2 to 4. But remember, with respect to y, it's the rightmost curve minus the left. The rightmost curve is your diagonal line. What is that though? Don't say it's y equals x minus 1, which is what we started with. We use our x equations in terms of y. So the right equation, it's still the diagonal line, but which one is that? It's the y plus 1. So that's the upper limit. Minus I'm sorry, not the upper limit. It's the rightmost limit or the rightmost curve. My leftmost. Well, the left is that bowl shape. Right? What was that bowl shape with respect to x? It's the y squared minus 6 over 2. Now, instead of me saying y squared minus 6 over 2, I'm going to say minus and then parentheses 1/2 y squared minus 3 dy. Where am I getting that from? It's because what's y squared divided by 2? 1/2 y squared. What's negative 6 divided by 2? Negative 3, right? That's where that's coming from right there. I divide this 2 into everything up top. That's where the 1/2 comes from. Don't just go 6 divided by 2 is 3, and then just leave this as y squared. No, it's still 1/2 y squared because you have to divide 2 into the y squared. I did that because it's just going to be easier to combine like terms and find the antiderivative. So we're still not going to integrate yet. I'm going to drop the parentheses. This is y plus 1. And then minus 1/2 y squared plus 3 dy. And what is this equal to? Well, this is negative 2 to 4. And I'm going to put it in descending order, right? So negative 1/2 y squared plus y and plus 4. And all that still is we're still integrating with respect to y. Now we're going to keep going. Let's take the antiderivative of this right here. So antiderivative of negative half y squared. Well, remember, if it was just y squared, it'd be 1/3 y cubed. Because you have a negative 1/2 in the front, you can multiply the 1/3 times the negative 1/2, so you get a sixth. So you're gonna have negative 1/6 y cubed, and then plus 1/2 y squared plus 4y, evaluated from 4 to -2. So again, negative 1/2 y squared, the antiderivative of that became negative 1/6 y cubed. Why? Because again, if you look at it, remember it's negative 1/2 times 1/3 y cubed, right? Going y cubed over 3. But since you have the negative 1/2 on the front, you multiply, you get negative 1/6 y cubed. That's where that comes from. Okay, if you need to work that off to the side right there. Now we're going to plug in these limits, right? So we have the upper one. Again, watch the signs. This is negative 1/6. And this is 4 cubed plus 1/2. 4 squared plus 4 times 4 minus the higher bottom limits, negative 1/6. So negative 1/6. And then we're going to have negative 2 cubed plus 1/2 negative 2 squared plus 4 times negative 2. Don't forget minus the entire bottom limit. Watch the negative signs. Watch the negative signs. Watch the negative signs. The arithmetic, right? Watch all that stuff. And when you work it all out, you should come up with positive 18. Again, you can throw all this into the calculator. Just watch this. Watch the parentheses. You need to do little parts, right? Bit by bit. It's okay. Like this is negative 64 over 6, right? This right here, this is 6 over 2, which is just 8. This is 16. That write it out step by step right here, same thing. And when you crank it all up, you should get 18. But again, really important. When you most people get the with respect to x ones correct a lot more because the equations it's always y equals something with a bunch of x variables. But when they shift to the y, you got to remember little things, right? Like your equations always be in terms of y's. It's got to be x equals all y stuff, correct? And your limits have to be in terms of y as well. That will most likely require manipulation of either one or both of your equations. It just depends on what they give you. And remember, for the equations or integrating with respect to y, it's the rightmost curve minus the leftmost curve. When you're integrating with respect to x, it's the upper curve minus the bottom curve. Now, if the problem gives you the boundaries, correct, then you don't have to find limits. You just integrate with respect to what gave you. Take your time with these problems because, again, there's just a lot of little places where you can mess up. And again, watch the arithmetic here, okay?